But to get back over here, it really helps to add these things. When we make it foo again this time, when we come back over to your editor, it's going to complain. Why? Because it made a new map and it made a new list. You're going to get this kind of a, ugh, but you got to read it. The file has changed externally. Yeah, it did change. We want those changes. Yes, reload them all. Okay? Now we can look at our mapped file and notice there's a lot more over here. And what do you know? Actor length at offset 3. The first 4 digits don't matter.
What are those?
Well, you got 2, 0 and 16. See it? There's only 2. What do we have? Well, actor length is at offset 3 in something that's at 16. Whereas copy buff is at offset E5 in something that's 0. Copy buff is a proc, isn't it?
Yes.
Act string length is data. The data segment is 16 pages past the code. Got it? That's what it's saying. Okay. It can get more complicated than that, but you'll notice that they happen to be exactly that. And that's why it sorts them also by address. These are all coded, these are all data segment values, these are all code values. Make sense? Got it? That really helps because now between the list file, where we know we're doing the work, right before we do int21 at address, what, 25, right before that, we ought to be able to look at the buffer to see if it's set up right. Now we can come back to symdeb, foo.exe, go but stop at 10, because we always do that. Then we figure out where we want to stop. Unassemble at 1B, yeah, that's what it is. Go but stop at 25, right there. And I want to look at actual string length. No I don't. I want to look at max string length. Max string length is the beginning of the buffer that we need to use. What's max string length? Max string length is offset 2. And now your next most valuable command. If unassemble is for doing things, if R and U is for looking at code, then D is for looking at data. And it doesn't stand for data, it stands for dump. Dump byte at address 3. Oh no, wait, sorry. Max string length 2. And what do we have? 40, 0, and a bunch of zeros. What's 40 hex?
32, I mean, 64.
Capital A?
64. 64 is the length of your buffer, isn't it? Absolutely. Actual string length, is at offset 3. That's offset 2. 3 is 0. Yeah, that fits because he just set it to 0. Okay. And then a bunch of zeros after it. Do we have enough zeros after it? Should be zeros all the way from here. 1, 2, 3, 4. And the very first thing that's after it is a bunch of 20s, a bunch of blanks. Yeah, that kind of fits. Look at his data area.
Oh, there's a bunch of...
Here it is. There's 64, 40 hex. A 0 that he put there, 64 zeros. By the way, if it gets confusing, you can really change this to something that's specific. Question mark, an actual character, or a star to make it real obvious, or I for the input buffer. Question mark just says don't initialize it. Actually initialize it to 0. But what follows it? His edit input buffer, which is a bunch of blanks, a $sign, and 1310. Yep?
Yeah.
Good, good, good. So that's in context where we are. Are you? It's all set up right. R, T for trace. What are we doing? It's waiting for user input. It's executing that instruction. Okay, what do you want me to enter? This is the string. We need, this. We need something that's non-alphabetic.
The little squiggly line.
Of course, is my
And the
string.
brackets.
Anything else?
The little Java brackets, whatever they're called.
We got spaces. We'll do some other things
Checking
just
out.
for fun. And as soon as we hit enter, it's back to our code and it breakpoints. T executes one instruction. But if the instruction is int21, go to the operating system, it goes to the operating system and does all its work. And then comes back and breakpoints. That's what this is called, breakpoints. If we want to stop it at that place every time, there's another one. We can literally say BP for breakpoint, address is 25, and it'll always stop at address 25. BL shows you the ones that it'll always stop at. We just did our buffered input, which should have changed what? The input buffer, right?
Or the
User input.
Yeah.
Okay, user input starts at address 4, dump, byte, 0004, or just 4. This is, of course, my string, blah, 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 all the way through, and there's a 0D right there, which is the enter key. At the beginning of it, though, we should go back one level from that, dump at address 2 to see the whole buffer. It stayed 40. Oh, the length that I entered is 23 hex. What is that?
23 hex.
35.
35. Very good. 35 characters, and we should be able to literally compute the address and make sure that it's there. And you will notice if you do compute the addresses that the 35 does not include the 0D. Okay? Very useful.
13 because that's entry,
It's
right?
easier in terms of hex. It's 23 long starting here, right? 1 down is 10. 1 down is 20. 1, 2, 3. Got it? That's the first one after my stuff. Got it? Got it? Got it? Got it? Got it?
Gotta play with this more.
So that part's working pretty good. This is how you execute in the debugger. T, trace for a single